The Champion 8400 is like no transmission you have ever experienced. Forget the awkward levers and clumsy shift patterns of ordinary transmissions. The 8400 microprocessor controller lets you match 8 forward and 4 reverse gears to your working conditions with unprecedented ease and precision. One of the first things you will notice about the 8400 is the digital display on the controller. When you turn the ignition key to the on position, the 8400 uses the display to introduce itself with a set of 3 codes we call the startup sequence. The first code you will see are the letters CH. This, of course, stands for Champion. Next, you will see an issue number, like 1.7. This number identifies your controller if it should ever need service. Finally, the controller will show the number 8.8 as a way to test all the elements in the display. One of the most exciting aspects of our new transmission is its intelligence, and part of that intelligence is its memory. Whenever you shut the grader off, the 8400 remembers the last gear you selected. After completing the startup sequence with the mode lever in neutral, the display will alternate between the gear the controller has memorized and the corresponding gear in reverse. Reverse gears are signified by a minus number. For example, if you were using third gear forward when you shut off the grader to take a break, the display will alternate between the number 3 and the corresponding reverse gear, -2, when you start the grader up again. This ensures that the same gear is available to you when you want to resume your work. Let's see how easy it is to use the 8400 transmission. If you want a higher gear than the one shown in the display, just push forward on the pulsar lever and release it. The display will show the number of the new gear. To select a lower gear, pull backward on the pulsar lever. Start the engine. The engine will not start unless the mode lever is in neutral. Depress the clutch pedal and move the lever to the forward position. Now smoothly release the pedal and the grader will move forward in the gear you have selected. Accelerate to the desired engine speed. To change gears, let up briefly on the accelerator and push forward on the pulsar lever. The transmission will shift up and the display will show the number of the new gear. When the grader is working against a load, you don't have to let up on the accelerator to make smooth shifts. Changing directions is just as easy. Slow the grader down, depress the clutch pedal, and use the brakes to bring it to a complete stop. Move the mode lever through the neutral gate and into the reverse position. The display will automatically show the number of the corresponding reverse gear. If you want a different gear, use the pulsar lever to select it. Release the pedal, and the grader is once again in motion. You can shift up or down, in forward or reverse, without ever using the clutch. The 8400 will make the gear change in less than a second. While the 8400 is helping you select gears, it's also looking after itself. The controller is constantly checking on the condition of the electrical components of the transmission system. If it detects a malfunction, the display shows an error code, the letter E, followed by a code number. The error code number pinpoints the location of the problem to speed up repairs and get you on the road again. You can find a listing of error codes and their meanings in the operator's manual. We think you'll enjoy using the 8400 transmission. Changing gears has never been easier.
This program is the first in a series covering Champion's 8400 transmission. The other programs are 8400 transmission removal and disassembly and 8400 transmission clutch packs. We recommend that you view this program first. The 8400 transmission is part of Champion's modular powertrain. It's an electrically controlled full power shift transmission with 8 speeds forward and 4 reverse. The case is of cast iron. Lubrication channels are cast into the casing to supply bearing lubrication oil, and this eliminates most external tubing. Internally, the transmission is comprised of 5 shafts supporting 14 gears. 7 are clutch gears and 7 are splined. 12 of the 14 gears are helical cut, the remainder are straight cut gears. The 5 shafts are supported by tapered roller bearings of 2 different sizes. Specified bearing end float is 0.002 to 0.007 of an inch, and this is achieved by the use of 1 spacer per bearing. The spacers are available in increments of 0.005 of an inch. For any forward or reverse gear, 3 of the 7 clutches are engaged. Different combinations of 3 engaged clutches provide the required transmission ratios. The double clutch packs have a common piston and housing to prevent both sides from locking up together. The transmission is operated through an electronic controller. Electrical circuits energize solenoid cartridge valves in the gear shaft collector caps. These valves select which clutches receive lockup oil pressure or lube oil pressure. The transmission hydraulic circuit includes lubrication of the engine clutch and, if the machine is equipped with a differential final drive, oil pressure to the lock-unlock piston. This hydraulic circuit is separate from all other systems and is equipped with its own pump, cooler, and filter. The cooler and filter are equipped with bypass valves. Mounted on the transmission is a 2-spool regulator valve. One spool maintains 165 to 185 psi for clutch lockup. Excess flow is directed to the lubrication spool, which provides oil for lubrication and cooling of the transmission clutches and the engine clutch. The regulator valve limits lube pressure to 25 psi and directs any excess to the transmission sump. This troubleshooting program is designed to introduce procedures that will repair most hydraulic and electrical malfunctions. In the majority of cases, the last procedure that may be required is the transmission rebuild. Performing electrical and hydraulic systems testing first will normally prevent the need for a costly, time-consuming mechanical overhaul. When beginning electrical troubleshooting procedures, always ensure that the transmission is in neutral, the engine is off, the parking brake is on, and all implements are lowered to the ground. Field troubleshooting reports indicate that the majority of controller problems can be attributed to a poor ground. Always check for a poor ground first. The problem could be between the cab and the controller, between the cab and the frame, across the articulation hinge, at the isolation switch, or at the battery. When you start the engine or turn the key to the run position, the transmission controller display shows a series of codes known as the start sequence. CH for champion, 1.7 a controller revision number, 8.8 for display testing, the last gear memorized, and the corresponding gear in opposite direction. If this sequence is not displayed, look for a tripped circuit breaker and reset it if necessary. If all circuit breakers are normal, remove the screws retaining the console and lift it up to expose the controller. With the key on, look directly behind and to the left of the LCD display for a green or red light. If the green LED is on, the controller is functioning properly. If the red light is on, the controller has malfunctioned and may have to be replaced. If no light is on, power to the controller is below 9 volts. Check the power supply and ground to the controller. If the green LED is on but the display is blank, remove the controller and test for power at the microswitch terminal labeled Common. There should be power if the ignition switch is on. If there is no power, check the continuous duty solenoid under the console. If there is power at the Common terminal, ensure the mode lever is in neutral, and check the terminal marked Normally Open for power as well. Then move the mode lever to forward or reverse. Now there should be power to the terminal marked Normally Closed. If either of these two situations is not the case, replace the microswitch. The transmission controller has self-diagnostic capabilities that continuously monitor the transmission's electrical system. The display will indicate an error by alternately flashing E and a 2-digit code. You'll find the error codes listed in the operator's manual. Whenever one of these error codes is displayed, the transmission will internally shift to and remain in neutral. To reset the controller, the mode lever must be returned to neutral. For example, if the power supply voltage to the controller is between 8.5 and 10 volts DC, the error code E1.0 will flash. This indicates either low batteries if the engine is off, or a faulty charging system if the engine is running. If the power drops below 8.5 volts DC, the display will be blank. E2.7 indicates an open circuit in the power supply to all 6 solenoids. The first check is at the 15 amp circuit breaker. If the breaker is OK, check for power at the continuous duty solenoid. The breaker, the microswitch, and at the single blade connector between the transmission and main supply harness. Error codes from 2.0 to 2.6 indicate an open circuit in one of the transmission solenoids. E2.3 is an open circuit solenoid 6, for example. Look for a broken wire or a short to ground. You should also check the resistance of the solenoid against the values listed in the shop manual. If the resistance is high, replace the solenoid. If the resistance is normal, reconnect the solenoid to the transmission harness. Disconnect the single-pin connector at the controller and check the resistance from there to the appropriate pin on the transmission harness. If the resistance is once again infinitely high, the fault lies in the transmission harness, and it should be replaced. The controller will not allow transmission operation with an open circuit. Short circuits are failures where the current bypasses the solenoid. They are indicated by error codes 3.0 to 3.6. E3.3, for example, is a short circuit in solenoid 6. As long as the operator does not select a gear that requires activation of the short-circuited solenoid, the transmission will function. To troubleshoot a 3-series error code, disconnect the 2-pin connector at the solenoid in question and check its resistance. If the value is below specification, replace the coil. If the resistance is normal, reconnect the solenoid. Disconnect the single-blade connector and the multi-pin connector at the controller. Check the resistance between the single connector and the appropriate pin. The value should be slightly higher than that of the solenoid coil. If it is far less, you must replace the transmission harness. Error codes 4.0 and 4.1 are for forward neutral and reverse neutral controller input errors. When the operator shifts from either forward or reverse to neutral, two steps must take place. The magnet on the mode lever arm must move away from a proximity switch, and the micro switch must be depressed. If these two steps do not occur, one of the 4 series error codes will be activated. Check for a missing or misaligned magnet. Refer to the shop manual for the correct clearances. If adjustment is needed, add or remove washers. You can also move the magnet laterally in the slot. The same condition may also be at fault if the pulsar lever is ignoring shift commands. Once again, check to see that the magnets are present and properly located. When a solenoid coil is activated, there is an electrical spike generated which could damage the electronics in the controller. Early controllers used a diode to dissipate this energy, but this relied on an effective ground. Often the diode was discarded in error. Current units use a varistor, which stores and then slowly releases the excess current. We recommend that you update the controller with a harness that includes a varistor, especially if the controller behaves erratically. As well, do not hook up any accessories such as radios to the transmission electrical circuit, including the continuous duty solenoid. There is an accessory solenoid available to power these types of equipment. The electronic components of the controller are sealed from the elements in a box. Rubber boots are available for the levers to protect the microswitch from dust. Recent production units have a gasket between the electronics box and the faceplate to keep the digital readout clean. These gaskets are available for installation on older units. As well, Champion has introduced a handheld tester that simplifies electrical troubleshooting. With this unit, you may check quickly for open or short circuits and verify shift sequences. To install the tester, disconnect the transmission harness from the controller and connect the test harness to the transmission harness. Disconnect the power supply connector and connect the tester supply between the two wires. Connect the tester ground clip to the main harness ground stud. With the mode lever in neutral, turn the ignition on. Once the startup sequence is complete, move the mode lever to forward. The controller will display E2.7. Press the button on the tester. 7 red LEDs should illuminate. Disregard the 2 upper right LEDs. Any red LED that does not light up indicates an open circuit in that solenoid. When you release the button, check for an illuminated green LED. A green LED indicates a short to ground. Turn off the ignition and rectify any indicated open or short circuits. Now connect the test harness to the transmission controller. With the ignition switch on and the mode lever in forward, cycle the pulsar lever through the gears and check the green LED patterns for the correct sequences. Repeat this procedure to check the reverse gears. Disregard the lower right LED if your grader is not equipped with a backup alarm or lights. Any abnormal sequences may be due to a faulty controller. The preceding electrical diagnostic procedures should resolve most 8400 transmission electrical faults. If the transmission still malfunctions, there may be a hydraulic or mechanical problem. The 8400 transmission is controlled by an electronic controller and solenoid valves which direct oil to the appropriate clutch packs. If the transmission does not operate correctly, and there is no error code or other electrical malfunction, the problem will be traced to hydraulic pressure, hydraulic flow, or mechanical failure. An important point to remember is that hydraulic flows and pressures should be checked first. This will reduce unnecessary transmission removals and rebuilds. Before starting any hydraulic troubleshooting, the grader must be in the service position, parking brake on, and all implements on the ground. It is also recommended that you block the rear wheels as an additional precaution. Before performing any pressure or flow checks, ensure that there is the correct type and level of transmission oil. If the warning light that indicates low lube pressure is on, or the transmission is not operating normally, check the lock-up oil pressure at the filter outlet. Record the pressure at idle and rated engine speed, and compare the results against the chart in the shop manual. In the case of low pressure, remove and check the filter for contamination, drain the transmission, then check the transmission sump strainer for contamination. Refill the transmission to the proper level. Check all supply lines for damage or suction leaks. If the grader is equipped with a lock-unlock final drive, and if the flow is at or above the recommended minimum, and main pressure remains low, block off the line from the filter that supplies the differential lock circuit. Should this cause clutch pressure to rise, there is excessive leakage in the differential lock circuit. Remove and inspect the differential lock valve and cylinder assemblies. This may also be a cause of low lube pressure. Should you fail to correct the pressure by these methods, the transmission pump should be checked for correct flow. Install a 40-gallon per minute flow meter in line between the transmission oil cooler and filter. Refill the transmission to the appropriate level. Start the engine and record the flow at idle and rated engine speed. If the flow is below that recommended in the shop manual, repair or replace the transmission pump. Look for excessive wear, cavitation, erosion, contamination, scoring, or defective seals and packings. If the main flow is normal and the main pressure is low, remove and inspect the lock-up pressure regulator valve spring. If the spring is not collapsed or broken, adding a shim between the spring and the spool may raise the transmission pressure to specification. If main flow and pressure is normal, but the low lube warning light is on or the transmission is not operating normally, follow the procedures outlined on the hydraulic test sheet found in the shop manual and record the results. It may not be necessary to complete the entire chart. Transmission lockup and lube pressures and differences for each clutch pack are specified in the shop manual. If clutch lockup pressure is low in the selected clutch pack, check the mechanical operation of the appropriate solenoid valve spool. Remove the coil and cartridge from the valve bore and inspect them. With the engine off but the key switch on, engage a gear that uses that valve cartridge. The valve spool should move freely. Also check the screens around the valve for contamination and check the O-ring for damage. If you reinstall it and torque it to specification and the valve fails to operate, the collector cap bore is probably distorted and must be replaced. Be sure the nut holding the coil in place is torqued to specification as well. If clutch lockup pressure remains low at one clutch only, remove the collector cap from that clutch. Inspect the seal rings for cracks, chips, or nicks. Inspect the internal bore of the collector cap. The seal ring grooves should be even around the inside diameter. If the low lube warning light is on, remove the sender unit and install a pressure gauge rated at 0 to 60 psi. Record the pressure at idle and rated engine speed and compare the results against the chart in the shop manual. If the lube pressure is low and main flow is normal, adding a shim between the spring and spool may raise the lube pressure to normal. If the transmission still malfunctions with the proper flows and pressures, or lockup flow to individual clutches is excessively high, a mechanical malfunction may exist within the transmission. Refer to the other programs in this series for transmission removal and clutch pack disassembly. Electrical and hydraulic troubleshooting will eliminate most transmission problems. Using these procedures means your champion grader will be back at work again more quickly.
The 8400 transmission is part of Champion's modular powertrain. You can easily remove the transmission from your Champion motor grader without disturbing the engine, final drive, or tandems. Before starting, make sure the work area is clean and safe. You will need blocks or stands as well as a transmission jack. Depending on the model, you may need to raise the grader high enough so that the transmission will clear the underside of the frame. Be sure to support the grader securely with proper stands or blocks. Remove the drain plug on the bottom of the transmission and drain the oil into a large container. Remove the suction hose from the transmission fitting. Remove the clutch drain line from the transmission. Disconnect the supply hose from the regulator valve. Remember to plug the open valve ports and hose fittings to prevent contamination. Remove the clutch supply hose and breather hose. Disconnect the electrical supply looms. Identify them to prevent confusion during reassembly. Disconnect the upper and lower drive shafts. Use the jack to support the transmission. Remove the transmission mount bolts. Use the jack to lift the transmission off the mounts. Pull the jack forward until the transmission is clear of the mounts, and then lower it away from the grader. Place the transmission on blocks, standing upright. Remove the suction fitting and suction screen. Remove the nuts and drive shaft yokes from the back side of the transmission. Rest the transmission on its back using blocks to support the case. Remove the hydraulic tubes from the control valves. If you intend to service the control valves, carefully remove the solenoids, nuts, and spacers. Remove the valve cartridges. Remove the cap screws from the control valves and countershaft cap. Use a hammer and chisel to break the seal between the valves or cap and the transmission case. Remove the valves or cap. Remove the cap screws that fasten the transmission case halves together, along with the transmission mounts and lifting eyes. Insert a flat chisel in one of the slots located at the top or bottom of the case. Strike the chisel sharply to break the seal between the case halves. Do not use a pry bar. You will damage the transmission case. Lift the front case half away. Remove the clutch packs in the following order: the intermediate clutch pack, the input clutch pack, the reverse clutch pack, and finally the countershaft. To remove the output clutch pack, you must first remove the oil baffle. Bend back the lock tabs and remove the cap screws. Rotate the oil baffle and remove it. Lift the output clutch pack out of the rear case half, but be careful. The output clutch pack is the heaviest component in the transmission. Disassembly of the 8400 transmission is now complete. If you intend to repair or overhaul the clutch packs, please refer to the companion program in this series entitled 8400 Transmission Clutch Packs. Before assembling the transmission, carefully inspect the shaft roller bearings and all gear teeth. Replace any damaged or excessively worn components. Install the yoke end of the output clutch pack in the rear case half. Install the oil baffle, cap screws, and lock tabs. Tighten the cap screws to the recommended torque. Then bend up the lock tabs. Install the shaft assemblies in the following order: the countershaft, the reverse clutch pack, the input clutch pack, and the intermediate clutch pack. The seal ring end of each shaft should be pointing up. Apply a bead of gasket eliminator to the mating surface of the rear case half. Carefully install the front case half. Install the cap screws along with the transmission mounts and lifting eyes. Tighten the cap screws to the recommended torque. The 8400 uses shims in each shaft bearing bore to allow for end float. Proper shim thickness is critical to the operation of the transmission. To determine the correct shim thickness for each bore, start by installing the special tool, part number 29858, with 2 cap screws. Tighten the cap screws evenly in 3 stages to the torque specifications listed in the shop manual. Use the deep reach socket, part number 29859, to rotate the shaft assembly in both directions after each torque stage. This ensures that the bearing rollers are fully seated. Recheck the final torque value. If necessary, retighten the cap screws, rotate the shaft, and check the torque again. Repeat this procedure until the torque value is correct. Remember, the torque specifications are critical to the final outcome of the procedure, so follow them exactly. Use a depth micrometer to measure through each of the 4 small holes in the special tool. Calculate the average of these measurements. Section 8 of the shop manual incorporates a special shim selection chart. Use the chart and the average measurement to find the correct shim. Check the shim with a micrometer. If the shim thickness is correct, install the shim in the bearing bore. Double check to make sure that there is end play. If in doubt, repeat the shim selection procedure. Remember, the wrong shim could quickly destroy the transmission bearings. Apply gasket eliminator to the mating surfaces of the control valves and countershaft cap. Install the valves and cap and tighten the cap screws to the specified torque. Connect the hydraulic tubes. Install the suction screen and fitting. Use a hoist to raise the transmission into the upright position. Apply gasket eliminator to the bearing face of both drive shaft yokes and install them on the input and output shafts. Install the lock nuts and tighten them to the specified torque. Place the 8400 on the transmission jack. Use the jack to move the transmission under the grater. Raise the transmission carefully into position. Ensure that the mounts are properly aligned. Install and tighten the mounting bolts. Reconnect the upper and lower drive shafts. Be sure to tighten the retainer cap screws to the proper torque. Connect the breather hose, the clutch supply hose, the transmission supply hose, the clutch drain hose, and the transmission suction hose. Connect the transmission wiring harness. The harness consists of 6 pre-coated wires. Verify the positions of the wires by comparing them to the connection diagram in Section 8 of the 700 series shop manual. Fill the transmission with clean, fresh lubricant up to the full level on the sight glass. Start the engine. Check the oil level in the sight glass and add more oil if necessary. Road test the unit to make sure that the transmission functions properly. Check all the connections for leaks. This concludes the removal and disassembly procedure for the 8400 transmission.
The following program describes the disassembly and overhaul of the clutch and shaft assemblies or clutch packs for the 8400 transmission. For instructions on removing the clutch packs, refer to the companion program entitled 8400 Transmission Removal and Disassembly. Clutch packs in the 8400 transmission are very similar to those used in previous Champion PowerShift transmissions. Begin disassembly of any clutch pack by removing the seal rings from the end of the shaft. Remove the lock nut. Use a puller to remove the bearing cones and any outer gears. For all clutch packs except the intermediate clutch pack, remove the outer thrust washers and the bearing element. Remove the gear and drum assembly. Remove the needle bearings and spacer. Examine the bearings for excess wear or damage. Remove the inner thrust bearings and washers. The gear and drum assembly for the intermediate clutch pack turns on tapered roller bearings. If you are working on this clutch pack, you will need a puller to remove the gear and drum assembly. You may find it necessary to remove the outer bearing cone before you can fully remove the gear and drum assembly from the shaft. Remove the cone spacer from the shaft. Use a puller to remove the remaining bearing cone. Examine the bearing cones and cups carefully. If either bearing element is worn, you will have to replace both the cone and the cup. If you must replace a bearing, use a drift to force one cup out of the gear and drum assembly. Remove the cup spacer from the gear. Remove the snap ring from inside and force the other cup out of the gear. Remove the spacer from all clutch packs. The spacer for the output clutch pack looks like this. Remove the retainer snap ring from all clutch packs except the output clutch pack. If you are working on the output clutch pack, remove the retainer cap screws. Remove the retainer half rings from the hub assembly. It may be necessary to push the hub assembly down against spring pressure to remove the half rings. Lift the hub assembly off the shaft. Remove and discard the spiral lock ring. And snap ring. Remove the backing plate. Remove the friction discs from the hub assembly and separate them. If you are working on the input, output, or intermediate clutch packs, you will have to repeat these procedures and disassemble the opposite side before proceeding further. When you have removed the opposite hub assembly, you can begin disassembly of the piston housing and force piston. Remove the snap ring. Use a soft-faced mallet to push the piston housing off the force piston. Remove the piston and housing from the shaft. Remove the snap ring that retains the accelerator piston. Remove the accelerator piston. Remove all hook-type seal rings and discard them. Remove the disc valve and the reinforcing disc. Take the inner and outer springs out of the separator plate. Remove the 3 dowel pins from the separator plate of all clutch packs except the reverse clutch pack. In the reverse clutch pack, the dowel pins are fixed. Remove the O-ring from the separator plate and discard it. Do not attempt to remove the separator plate. Thoroughly clean and inspect all components. Look for damage and excessive wear, especially to bearings, splines, and gear teeth. Ensure that all oil holes and passages are clear of obstructions. Replace all O-rings, seal rings, snap rings, and other retaining rings. Dip bearings in clean, fresh lubricant. Wrap them in clean, lint-free cloth or paper. Begin reassembly of the clutch pack by installing the inner and outer springs. Install the dowel pins in the separator plate of all clutch packs except the reverse clutch pack. Install the O-ring on the separator plate. Apply a thick coat of petroleum jelly to the O-ring. Install the reinforcing disc and disc valve. Align the holes in the discs with the dowel pins and install the piston on the shaft. Install the snap ring retaining the accelerator piston. Install new seal rings on the shaft. Install a new seal ring on the accelerator piston. Install a new seal ring on the force piston. If you are working on a reverse clutch pack, install the seal ring on the piston return plate. Fill the entire snap ring groove of the piston housing with soft copper wire or petroleum jelly. This will prevent the groove from cutting the separator plate O-ring. Install the piston housing and force piston on the shaft. In the case of the reverse clutch pack, install the piston housing and piston return plate. Secure the piston return plate with a new snap ring. Ease the lip of the piston housing past the separator plate O-ring. Do not force the housing past the seal rings on the shaft or accelerator piston. Allow the piston housing to compress the seal rings. Once the snap ring groove in the piston housing clears the force piston or piston return plate, you can remove any copper wire you may have installed in the groove. Install a new snap ring. Install internal spline friction discs on the hub assembly, followed by an external spline steel disc. Alternate friction discs with steel until all discs are installed. The last or top disc should be a friction disc. Install the backing plate on the hub assembly. Install the internal snap ring. Install the external spiral lock ring. Install the hub and disc assembly on the shaft. Push the assembly down against spring pressure and install the retainer ring halves. Secure the retainer ring halves with a new snap ring. Or, if you are working on an output clutch pack, install the retainer cap screws to finger tightness. Install the spacer on all clutch packs. For all clutch packs except the intermediate clutch pack, install the inner thrust bearing and washers. Apply lubricant when reinstalling all bearings. Install the needle bearings on the shaft. Install the gear and drum assembly on the shaft, taking care to engage the tangs of the disc with the slots in the assembly. Install the outer thrust bearing and washers. Note that the washers are of different thicknesses. Consult the parts manual for the appropriate thickness and location for each washer. If you are working on the intermediate clutch pack, install the snap ring and cup spacer in the gear and hub assembly. Apply a Champion-approved retaining compound to the inner and outer cups. Use a press to install them. Install the inner bearing cone with retaining compound and install the cone spacer on the shaft. Install the gear and drum assembly for the intermediate clutch pack, taking care to align the tangs of the discs with the slots in the assembly. Finally, install the outer bearing cone. Apply anti-seize lubricant to the shaft splines of all clutch packs. Install any outer gears. Use a press to install the gears firmly against the clutch pack assembly. To install the shaft bearings, we recommend that you heat the bearings in a dry oven or immersed in hot oil up to a maximum temperature of 120 degrees centigrade or 250 degrees Fahrenheit. Do not use an induction heater. Install the lock nut and tighten it to the recommended torque. If you are working on an input, output, or intermediate clutch pack, you are now ready to assemble the opposite side. When the clutch pack is fully assembled, install new seal rings on the valve end of the shaft. The clutch pack disassembly and reassembly procedure is now complete. Refer to the companion program entitled 8400 Transmission Removal and Disassembly for complete instructions on the installation of the clutch packs in the transmission.